Given two strings, word1 and word2, and a list of valid words in a dictionary, I'd like you to return the minimum number of operations required to convert word1 to word2. Hi everyone, and welcome to another mock interview with Exponent. Today we're here with Thomas. Would you like to introduce yourself first?
Yeah. Hi, everyone. My name is Thomas Kim. I am a former software engineer at Google, and I was working on the ads team. And now I recently jumped ship over to Instacart. So I'm trying something new, and we'll see how it goes from there.
Well, congrats on the move. That must be super exciting.
Yeah, definitely.
Since you're so fresh off the interview train, I'm sure this is going to be super valuable to our viewers. And I'll be sharing the screen just to share your thought process as you're working through the problem. And I'm excited to see what comes out of this.
Yeah, me too. Let's go.
So the question that we're going to be doing today, given two strings, word1 and word2, and a list of valid words in a dictionary, I'd like you to return the minimum number of operations required to convert word1 to word2.
Okay. So just some clarifying questions. So in this valid list of words, do I need to be concerned about like whether they're English words or if they're just like random characters?
I'd stick to English words, like valid English words that would be in the
Okay,
dictionary.
sure. And then will all of the words in this list or this initial set of valid words, are they of the same length or are they of different lengths?
Let's say they're going to be of the same length.
Okay. Okay. So then I think immediately when I start thinking of minimum edit distance, when I guess when I think of the edit distance or editing a word, it would probably be boiling down to like updating a letter. Since they're all since the initial list of words are all going to be the same word length, it's probably just going to be updating a letter. And since we're also
Mm-hmm.
thinking of minimum edit distances, that makes me think kind of immediately jump towards a graph traversal algorithm of some sort.
Mm-hmm.
And since we're going for a minimum edit distance, probably want to do something like breadth first search rather than depth first search instead.
Okay.
So I'll write out some code right here, def update word. I'll do words. That'll be the initial list of valid words in the dictionary, start word and end word. So just to lay out some pseudocode and some comments just to follow my thought process, it'll probably be first is to construct the graph of all of the words and any words that are one edit distance away from one another.
Mm-hmm.
So then I'll make another one like is another function is one edit distance between word1 and word2. So after we construct the graph, that's when we have to do the traversal of the graph. So we would traverse the graph here.
Mm-hmm.
Yeah, okay. So I think the first thing I need to do, I'll probably go into checking whether word1 or and word2 is one edit distance away from one another. So there's probably a few ways to do this, but in this case, since we're working off of the assumption that word1 and word2 are of similar lengths, what we can probably do is we can have a variable like different char count and set that to 0. And basically what we're going to do here is whenever a certain character between word1 and word2 aren't equal to one another, we will increment it by 1. And whenever we find the case that this different char count variable is greater than 1, then we'll just immediately return false, because that is indicating the words are not just one edit distance away from one another, they're like 2 or more edit distances away from one another.
Okay.
So we'll do for I in range of length of word1, and this is a fair assumption since we've already clarified that word1 and word2 will all be of the same length.
Mm-hmm.
If word1 of I isn't equal to word2 of I, then we'll increment the different char count variable by 1. And then if at any point during this process it is greater than 1, that's indicating that there is more than one character difference between the two words, and we'll just immediately return false. Else, if we go through the entire iteration without exiting earlier, then we'll just return true. So that should handle checking whether word1 and word2 is one edit distance away from one another. And then now we can start constructing the graph, where the graph is going to be a certain base word and then where the key is going to be a word, and then the value is going to be a list of words that are all one edit distance away from that initial word.
Okay.
So we can make a graph right here, one edit distance graph. Fix that typo. And now we will just start iterating for I in range of length of words. And then we will also say that the base word will equal to word of I. And then we're gonna have to do another iteration as well, another for loop for j in range of length of words. And then there's no use, like when I and j are the same, there's gonna be the same word. So we will check if I isn't equal to j. And we'll make the new word is equal to words of j. Oh, yeah, oh, sorry. Yep. There you go. Yeah, so then we will then check if the two words, base word and new word, are one edit distance away from one another. If one edit distance is one edit distance between base word and new word, then we will have to add this to the list or add this to the one edit distance graph. So first we will check if base word is in one edit distance graph first. And if that is, then we will just do one edit distance graph of base word and just append the new word. But then if this is the first time that we are encountering base word and this is the first word that we're encountering, that's one edit distance away, we have to make a new entry for that. So one edit distance graph of base word is equal to a brand new list of just the new word value. So that should, we love typos, gotta love that. So that should properly construct the graph. So now we can go through traversing the graph to actually return the minimum number of edits necessary to go from the starting word to the ending word. So since we're gonna go through like a breadth first search, like we could do it either recursively or iteratively. I think right now I just wanna do it iteratively. So we'll make a stack. And since what we're doing right now is going from the starting word to the ending word, and we're trying to count the number of edits between the starting and ending word, we're gonna need some way to keep track of how many edits so far we have gone through at a particular word or at a particular node if we're talking in graph terms. So like there's a lot of ways you can do this. We could theoretically create like a separate node class, like a word node class, and have two instance variables of like the actual word and edit distance. But in this case, since Python is generous enough to have allow tuples, I can just do the start word with the zeroth, and where the zeroth index of this tuple is the starting word, or is the current word we're at, and the first index of this tuple will be the distance or the number of edits that we are going to at that point. So we're initially going to start up the stack with the starting word, and the edit distance is going to be 0 because there's no edits done so far. And since we're also doing breadth first search, we're going to need to have a set that keeps track of all of the words that we've already visited, because there's no need to revisit the same word if we've already kind of encountered it before. Okay. So while stack current word and then edit distance is equal to stack.pop, and then for word in the one edit distance graph of cur word. So that should, now we're going to be iterating through all the words that are one edit distance away from the current word. If one edit distance, if word is not in the visited word set, then we will, then we also need to check if the word is not in the visited word set, we also need to check if this word is the ending word. If the word is equal to end word, that means we've kind of reached our goal, and we can just exit out immediately, and it'll be returning the edit distance +1. In the case that it's not the end word, then we would append that new word into the stack with the updated edit distance. So then that would be word and then edit distance plus 1. And we would then add that word into the visited word set. Add word. And then I think that should handle it. And then we'll also return null. We will return a null value if we find that there is no valid traversal from the starting word to the ending word.
Okay.
Yeah.
So let's go through an example. Can you come up with a list of words that you would give as an input to this to test out and like walk through whether this is actually working? Let's not run it yet.
Sure. So we can have like a list of words is equal to, let's say, like fail. Then we want to go to, let's say, fall, and fail. And let's see, if we start at fail, let's see what word we can go to. Fail, then that can edit to fall can edit to fail. And then let's say we want to go from fall to fail. That would be the starting word to the ending word that we want to go to. And then we also want to have some like dummy words to potentially throw this off as well to test it thoroughly. So from fail to fall, we can go from fall to FALT, and then from FALT, we can go to like FOLT. And yeah, so these are some other words that would take it down the wrong path if this were to fail.
Got it. So just to confirm, which fail and which fall are you talking about?
Yeah, right. So I'll start off with a fail like FAIL,
Okay.
and then let's say the edits that we want to, the end word that we want to go to is FALE.
FALE. Got it. All right. Okay, so if you were to do a quick walk through this example, what do you think like the intermediate steps would look like for this algorithm?
So it would go from FAIL to FALL and then FALE, since each traversal is just updating one letter at a time. So that's one edit distance. So then the output of this should be 2, because it's to go from FAIL to FALL and FALL to FALE. That's an edit distance of 2.
Okay, sounds good. So let's run this and see if this works.
All right. Let's see, update word of words, and then we'll start from fail and then fall. In true fashion, will errors come out? No, nothing. Oh, I should probably print the results. I am impressed. All right.
Great.
Maybe now errors will come out. Oh, okay. Edit distance of 1. Let's see where that went wrong. Oh no, sorry, I put the wrong inputs. So that was actually correct for the previous one. So now I'll update the ending word to FALE. So now hopefully it should be 2.
3.
Okay.
All right, let's walk through this. Let me know what your thought process is.
So let's go through how we construct a graph for edit distance-based words, and I J. We're getting the new word, and then we're checking if it's one edit distance away, and if so, we will edit that. We'll append that new word. If it's already existing, then we'll just append a brand new list with that new word. So now we're starting from start word and 0, visited word set, and then the current word and the edit distance is accordingly 0. Then if for a word in one edit distance of graph of the current word, we will first check if the word is not in the visited set. And in the case, if the word is equal to end word, we will return the edit distance plus 1. Else we would append the new tuple of the new word and increment the edit distance by 1, and we will add a new word. So I guess one thing that we can do to debug this would be, rather than just doing, we can actually try to see what the actual path would be.
Okay.
So just for debugging purposes, we can turn this from the edit distance to the actual, the path so far of the word.
Got it.
Right. So then we can just return 0 in this case. And then we would do current path, and then current path dot append word.
Mhm.
And yeah, so that should be printing out the, then we'll do return. So then this should allow us to see, oh, current path dot append. Current path dot append on line 24. Got it. Current path is equal to that. Word is equal to end word, return current path, stack dot append of word. And then that should be, oh, it's because the append function of current path actually returns none. So that's what's causing the error. So then if we just do that, we append it before and then just do the, just refer to the current path, then that should show us the correct path.
Got it.
Yeah, so fail, fall, fate, fail, fall, fate, fail, fault. Interesting. It's not
What would
expecting this.
what would your next step in the debugging process be?
Yeah, so the next step in this debugging process would be what we're seeing here is we're starting at fail and then we're going to fall. Let's see, fail to fall. That's the correct edit distance, correct edit. And then from fall, okay, so it seems like because when it's printing out the path, it's going from FALL to FAIT, and that is not one edit distance away, actually.
Yeah.
That is, so that's an issue. So maybe there is something incorrect about the checking of the one edit distance, or maybe in the graph traversal parts. Current word is equal to current path for word in the one edit distance graph of the current word. Yeah, so maybe there's something wrong with the one edit distance path, the one edit distance function, since that seems to be a failing point.
What so like if it is going into a part of the code that you don't expect it to go into, how would you be able to verify that?
Yeah, just start printing out to see what the results are.
Yeah.
So from here, I can print out the current word just to see what's like the base word, and then also print out the entire list of all of the words that are one edit distance away.
Yeah.
See what comes from there. So previously we were going from FAIL, okay. And then from FALT, that's the base word. And then it says all of the one edit distances are FALL, FALE, FAIT, FOLT. Okay, so it seems like, interestingly, it seems like the current word is actually never FALL. Ooh, what is happening?
This is my favorite part of coding anyways, just the debugging.
yeah, I mean, it's a big part of coding, so it happens.
Yeah.
Let's see. Current word for every single word in the one edit distance. So fail, those are correct one edit distance away, FALL to FAIT. Okay, so that's interesting. It seems like the current word is, this, oh no, it's not, FAIL, and then it goes to FAIT. Okay, so then from FAIT, then the two words that are one edit distance away is FAIL and FALT. And then from FALT, it goes to FALE. I see. So this is actually, oh, my bad. This is actually more of a depth first search approach.
Okay.
Because it started going off of the, from the most, yeah, because we're using a stack rather than a queue, because the queue, since we're going to be popping from the left, that should actually that should actually help us have a more breadth first search implementation rather than using the stack. So I believe that Python's list has a function for pop left. Oh, I had to do a deck actually.
Yeah.
So deck of this. Oops. Oh, okay. Import that. So from collections, import deck. There we go. And that should be the starting one. So then we would do dot pop left, I believe is the syntax. Yeah, so then we're going to be popping from the left and then right. Okay. Then this should be processing it one at a time rather than doing a depth first search approach like we were doing before.
Yeah.
So let's see how that would work. All right, I think that is, let's see, FAIL. Okay, yeah. So now we'll update this back to doing the edit distance since we were debugging with just the current path instead to visualize it. And then get rid of these print statements. Edit distance, and then return edit distance +1. Stack.append edit distance +1. And let's see. There you go.
Awesome. All right. So yeah, that was an interesting debugging exercise. I like seeing just how you think through that. So as a follow-up question, we don't have to spend too much time on this, but like, what if the initial list of words were not the same length? How would that change your approach?
Yeah, that wouldn't change the approach too much. I think a lot of the core things still remain the same. I think the one thing that would have to be updated is the checking the is one edit distance function. From there, we would probably have to check, take into account different words at different lengths. And really what that would entail would be, we would need to do a similar thing. Oh, but then in the case that two words are not the same length, the only way that they can be one edit distance away is if the difference in their length is only one. And then from there, they should actually have all of the matching characters should be exactly the same, because then if there is one character that's different and the length difference is also one, then that's minimum 2 edit distances away. So in that case, we would just need to check that all of the characters between two words that are of one edit distance, that have a difference of length of 1 has all the same characters to check for that.
Got it. Okay, I think this can conclude the interview part. Thanks so much, Thomas. This was really interesting to go through. How do you think you did?
Yeah, overall, I did pretty well. Obviously, it would have been better if I kind of figured it out in the beginning and used the queue. But I think in any real interview scenario, you're going to go into these moments where you realize like, oh, your code's actually not working, and debugging is a huge part of the interview process. So I'm kind of happy that this unexpectedly went poorly, because then it'll actually be better in the end of it to show what a real software engineering interview is like.
No, absolutely. I really liked this interview because I thought that it really illustrated well how a candidate can like start off really well, have really good structure, and no matter how hard you try, you're going to eventually run into some problems. And if you don't, you're lucky. That's the exception.
Definitely.
Yeah. So I thought this was, I'll go through just like some high level feedback I have, and then we can talk about maybe what advice you have for other people when they're going through this. I think it was good that you started off with high level thinking. You didn't dive into the problems straight. You started talking about just on a high level, how would you structure an algorithm to do the task that you were given. And then you discussed like, BFS versus DFS, and that was sort of I was starting to see just how you were visualizing the problem as well. Of course, like in an ideal situation, we'd have a whiteboard in front of us so you could draw things out, which I think is very helpful. In place of that, I would recommend just like doing, you know, the lists that you were printing out at the end, I would recommend just like drawing that out in text form to show what the steps would be for an algorithm that you're thinking of.
Right.
Yeah, in place of drawing something on a whiteboard. And then going on to the debugging part, which I think was the biggest part of the interview, I honestly think like with debugging, you really get to see what kind of engineer you're going to be working with. Because that's the real problem solving. Because like debugging, you have a limited amount of time, you need to figure out what's wrong, and it's very easy to get flustered. So just taking a step back, which you did, and just making sure that you had some strategies in your mind, like printing things out or trying to figure out, like isolate which part of the code might be going wrong based on the output that you were seeing. These are all techniques that really help in the moment to think through that problem and get a fix quickly.
Yeah, absolutely.
What advice do you think you'd have for someone going through this?
Yeah, I think a lot of very similar things as to what you said. Definitely try to map out from a very high level first. Don't start coding immediately, because every single question, like whenever like a small bit of information is given, it's usually given for a reason. So you should really like kind of center in on it. Like, what does this purpose, what purpose does this piece of information solve? Yeah. And definitely communicating and just talking out loud about your thought process is super important, because I think while it is important to get a working solution at the end of it, I think it's really important for the interviewers to see, how do you approach a problem? How do you, break down certain things in smaller portions that are more approachable? And lastly, definitely with, getting flustered and getting a little bit, especially in an interview setting, it's very high stress. It's easy to psych yourself out. And, if only it was easy to just write codes that never had any bugs. Maybe one day some people can do that, but definitely not for normal engineers like myself. So definitely during those moments where you kind of run into a wall, your code's not working, just to keep yourself cool and just keep your mentality in check, because once you start psyching yourself out, the interview is going to be a very, very steep drop downhill.
Yeah. And just think about it this way, like debugging is still valuable insight for the interviewer. They want to see how you think, and they want to see how you problem solve. Definitely. We've both been working in the industry for a few years now. I still write buggy code. I can't.
Oh yeah, it happens all the time. My go-to debugging strategy is still printing out stuff during my code. It's the best way to do it.
You can have the most sophisticated step-through tools. I'm still going to have print statements all over the place trying to figure out what's going on.
Exactly.
Thanks so much, Thomas. This was super valuable, and I hope everyone watching at home enjoys this and gets some value out of it as well. And good luck with all of your future interviews, everyone.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching, and good luck on your upcoming interview.